function f such that f of x equal to 2x cubed plus 5x squared minus 4x minus 3, where x is an element of real numbers, show that x minus 3 is a root. To show that something is a root, you sub it in. So we sub that in for x. And if it's a root, it should be equal to 0. So f of minus 3, click, click, click in the calculator, we get 0, hence it is a root. Okay, now we got to find the other roots. So what I'm going to do is x equals minus 3 is a root. Then I'm going to create a factor. X plus 3 is a factor. What can I do with factors? I can divide factors in, and I get a remainder of 0, and it'll reveal my other factors on top. So off we do, we're going to do our long division. X plus 3 is going to go into 2x cubed plus 5x squared minus 4x minus 3. Okay, dividing in, x into 2x squared goes 2x squared times, give me 2x cubed. 2x squared multiplied by 3 will give me 6x squared. I'm going to change my signs. 5x squared minus 6x squared will give me minus x squared. Then I have my minus 4x. X into minus x squared goes minus x times, minus x squared minus 3x. That's plus, and that's plus. Okay, x squared minus x squared is 0. 4x minus 4x plus 3x is minus x. And we bring down our minus 3. X into minus x goes minus 1, minus x minus 3. Change our signs, and our remainder is 0. So our other factors will be located on top, and we'll use those factors to find our roots. So it leaves us with a quadratic. So to factorize a quadratic, I'm going to use my roof method. 2 by minus 1 is minus 2. Factors of 2 to give me minus 1 will be minus 2 multiplied by 1 will give me minus 2. When I add them, I get minus 1. So I use those two numbers to replace the minus x in the middle with minus 2x plus x minus 1. And then I factorize by grouping. 2x times x minus 1 plus 1 times x minus 1. Check your brackets are the same. They are. So my two factors are 2x plus 1, x minus 1. Equals 0. So how do I turn factors into root? You let each factor equals 0 and solve. My 1 comes over to become negative 1. X is equal to minus 1 over 2. X is equal to 1. So these are my two other roots. Okay, I've got 2x cubed plus 5x squared minus 4x minus 3. I have to find the maximum and minimum point, so those are keywords for us. That means we have to get the derivative, f prime of x. Okay, so for maximum, we let that equal to 0. So the derivative here, 3 comes down in front to multiply, drop the power by 1. 2 comes down in front to multiply, drop the power by 1, and minus 4x becomes minus 4, and minus 3 goes to 0. For a max or a min, the derivative is equal to 0. To do that, you can factorize, you can do whatever you wish to do, but you might notice that it's equal to 0 here, so I can divide everything here by 2. Give me 3x squared plus 5x minus 2. I'm going to factorize using the roof method. 3 by minus 2 is going to give me minus 6. Factors of minus 6 give me a positive 5. Minus 3 by minus 2 is minus 6. When I add them, I get minus 5. That's not going to work for me. So I'm going to try minus 6 by 1. So minus 6 by 1 will give me minus 6. And when I add them, I get minus 5. Again, it's not going to work for me. So I'm going to reverse it. I'm going to do 6 by negative 1. 6 by negative 1 is negative 6, and when I add them, I get a positive 5. Bingo. Perfect. So these are the two numbers I'm going to use. 3x squared, so I'm going to replace the 5x by 2 of those numbers, plus 6x minus 2 is equal to 0. I'm going to factorize by grouping. 3x is common, leaving with x plus 2. Minus 1 is common, leaving with x plus 2 equals 0. So I'm going to factorize both of those. So 3x minus 1, x plus 2 is equal to 0. And solving, let each individual factor equals 0. 3x minus 1 equals 0. X plus 2 equals 0. And solve. Minus 1 comes over to become positive 1. X comes over to divide. So it gives you 1/3. 2 comes over, I get minus 2. Okay, so this gives me two values for x. I want coordinates, so I need y values as well. So to get y values, they need to go back into the original function. So the original function of f of x is equal to 2x cubed plus 5x squared minus 4x minus 3. And I'm going to feed each one of those in. So the first one I'm going to put in is 1/3, and that's going to equal 2 times 1/3 to be cubed, plus 5 times 1/3 to be squared, minus 4 times 1/3, minus 3. I'll calculate that in a second. And the second one I'm going to put in is minus 2. So it's going to be 2 times minus 2 to be cubed, plus 5 times minus 2 to be squared, minus 4 times minus 2, minus 3. Perfect. So f of minus 2 is equal to, so you get minus 100 over 27, and I get 9. Okay, so my 2 points there will be 1/3 minus 100 over 27, and minus 2 and 9. It's pretty obvious which is which. The minus 100 over 27 is obviously further down the y-axis, so that's going to be our min. So that makes this our max. Of course, you're supposed to put them in here. So the last part of this is a little bit tricky. So f of x plus a, where a is a constant, has only one real root. Find the possible values of a. Okay, so if you have a function, what does adding or subtracting a number do? It just slides the function up or slides the function down. We have a cubic here. We notice that this is a positive value here. That means it's going to be u-shaped at the end. So this is the shape of it. Okay, so we've got our minimum point here is going to be 1/3 and minus 100 over 27. Of course, our maximum point is minus 2, 9. Okay, we notice here now that we have 3 nice neat roots. So by adding or subtracting a number, we're shifting it up and shifting it down. So what they're saying is, how far up would you have to shift it, or how far down would you have to shift it, so that you've only one real root? Okay, so imagine now if I slid this up, slid it upwards direction, so that it no longer, this was no longer below the line, it was just above it. It would still come up to a peak up here. Now it would still have to cross down here, so we give you one real root. How far up would you have to shift it? Well, obviously it's the y value. So as long as I was able to shift it up a value of 100 over 27, that would work fine. But I could also do that by sliding it down. So again, we have our function. So imagine if this time now I slid it down, then it would be, this would no longer hit the graph. But of course this part of it would hit the graph because it continues forever and ever. So this would of course have to come down a distance of 9. So it would have to come down 9. So what could a be? Basically, as long as it goes up more than 100 over 27, so as this a is greater than 100 over 27, or it goes down, so it has to be kind of a number less than minus 9 to shift it down. As long as it's one of those two, bigger than 100 over 27 positive, or to slide it down we take away 9, it'll only hit the x-axis once and it will only have one real root. The other two roots will be imaginary.